and subscribe. Hello, this is North America Math Contest Go Go Go, and this week we are going to continue talk about limit and calculus. So for the last week we have talked about what is limit. Yes, remember. Limit is just getting infinitely close to the value. And transformations, basic function knowledge, which is taught, in pre-calculus 12. Okay. Let's continue start about this. So we can give an example about how limits will work. Okay, we give an example. So this is a function. We are going to get this. We can say, so we redirect the definition of limit is that the limit is getting infinitely close to the value. Okay. So it is like this. So it is just get infinitely close to x equals to 2, the axis. So we know that the value for it at x equals to 2 is 4 minus 8 plus 3 is -1. So if we get to x plus 2, the x-axis is growing and it is definitely getting infinitely close to the place where x equals to -1 is located. So you can just calculate it. Just plug in x is equals to 2. So we can say that for most of the limit functions, you can just plug in the value of this. You can just plug in the value of this to here in order to get this. If there is no calculation, there's no specific things where it cannot be calculated. Okay, so what is called the specific things that cannot be calculated? In this case, it involves in dividing by 0 or negative roots. For example, okay, actually, I can tell you this is does not exist. So in this case, if you just plug it in, you will find that it's equals to this, which is no real value. Okay, just we don't consider imaginary numbers here. Okay, so if it does not have the following, the mathematical calculation errors like this or dividing by 0, then you can just do it. So we are going to give you another example. Lim x equals to 3, x plus 3. I will give you 5 seconds. Get the answer. Okay, 5 seconds is up, and the answer is 6, because plugging this to here, 3 plus 3 is 6. Okay. So, in this case, we are going to talk to you about some basic formulas about limit. But, actually, I'm just going to say that after you have learned L'Hopital rule, after a few chapters, after you have learned derivatives, you find that L'Hopital rule is much easier compared to you use formula and calculate them, actually. Okay, here, let's go. So we give a basic few rules. First is some rules. Okay, first we should say that if this and this both exists, this is important because if they Either of them don't exist. You cannot just put them inside and calculate. Okay, so if this and this exists, then this is equals to this plus this. This is equals to this minus this. Lim x to c gx. Product rule, which is this, when two functions multiply times gx, they will equals to this times by this. Lim x c gx. And the division rule, divides by lim x to c gx is equals to lim fx divides by gx. So this is the division rule. And the constant rule is this k is equals to this. And let's see some more rules. And there is still constant multiple rule. It is like this. If this kfx, it is equals to k lim x to c fx. Yes. If k is a constant. And the power rule, n is equals to this. I mean, actually, when you're actually doing AP tests, I mean, these formulas, I mean, they won't actually test a lot about limit, just to say. Okay, but let's just continue. Properties of limits. Okay, so for these problems, you are able to solve one type of problem. Let's give you an example. FC is fx is equals to 6. So this is the problem. Given this problem, you will find this problem very easy if you have learned the properties of limits. So I'm going to give you 20 seconds to find the answer. Is that okay if I close the line? Okay, 20 seconds is up. So, lim gx, using the division rule, we can get that 3gx is equals to 9. And using the sum rules, you can get the final answer is 15, because 6 plus 9 is 15. Okay. Next, we are going to talk about an important definition. Continuous. The function is continuous is that every single real value of x has a limit. real value of x has a limit. I'm just going to think it in this way. So this is called continuous. There is a theorem. I forget what name is it. It is saying that the theorem. This theorem is that a function is continuous if you can draw it. I mean, if you can use a pen to draw it without lifting your hand. So this is continuous because you can draw it without lifting your hand. But this is discontinuous because if you draw it, you have to raise your hand to get the next one. Okay, so we are going to talk about ways of calculating limits that involves infinity. The infinity. An example is this. So for this type of problem, you can just think it as infinity. If we can call it huge, 1 over huge is 0. This is a type of problem. Another type of problem is that you will face a problem like this. Lim x to infinity. Okay, so it is at when it's at infinity, you need to remember that the exponential growth of this with a larger power will always grow faster than this. This will always grow faster than this. So it must be it must be equal to infinity. So if you see a dividing function like where it has a larger power compared to the 1, so it must be infinity or 0. If the larger power is at up, it is infinity. If it's at down, then it's 0. And another thing. 3x squared plus 8x2 plus x. Okay, I'm going to give an easy one because, 7 plus 6x plus 7. 3x squared plus 11x plus 8. So for this case, you only need to divide it by the highest power, which is x squared, plus 11x squared. So you get that the result is going to be 4 plus 6, 6 divided by x, plus 7 divided by x squared, 3 plus 11 divided by x. This is going to be 0 when it's getting infinitely large. This is going to be 0 when these are all going to be 0 when it gets infinitely large. So the result for it is 4 over 3. Okay, here we end this week of limit. For the next week, we are going to talk about the limit and the basic definition of derivative. So therefore, see you next week.